for being here. This is a poster about cognition networks in collaborative learning among Japanese youngsters and elders. The motivation behind this research is that in Japan we have a super aging population. The life and health expectancies are high, and that includes lifelong learning, which means that elders have a lot of opportunities to keep learning. So this gave us the opportunity to conduct a first research about collaborative learning and compare Japanese youngsters and elders. We did this through network science, in a specific cognitive network science, which can provide us with models and can help us observe learning processes. Therefore, the objective of this study was to provide a quantitative and qualitative comparison of Japanese youngsters and seniors' cognitive networks. The first research question was the quantitative aspect, and the second research question was a qualitative aspect. What we did was to consider the interactive, constructive, active, passive ICAP framework of cognitive engagement by CAI, and we used 15 ICAP indicators divided in 3 dimensions, manually coded by one of the researchers. We employed 2 datasets in this study pertaining to 26 students, university students, and 26 seniors, in a laboratory setting and separated according to age. The task objective in the laboratory was to learn about attribution theory by drawing concept maps with a computer, consisting in 5 steps. Learn attribution theory through key concepts and a case study provided by one of the researchers. Next, we have an individual pretest. Next, they draw a concept map individually using CMAP tools in a computer. And then they get together in pairs and they draw a concept map in pairs based on the individual maps. And finally, we have an individual post-test. Therefore, to answer research question 1, we employed the Japanese text analysis tools first to obtain word frequency and part of speech of the conversations. These conversations were recorded in video first, then they were transformed in audio and then in text before going through Japanese text analysis tools. Next, each participant conversation was structured as an undirected co-occurrence network in KH Coder, which is a software that can manage Japanese text and was developed by a researcher in Ritsumeikan University. Then we had to migrate these conversation networks and also the concept maps to a more mainstream network-based tool called Gephi. We used Gephi to calculate centrality measures of each network and aggregated students and elders networks. So after that, we had several network measurements, so we could calculate the Spearman correlations between ICAP and centrality measures of participants across age groups. And also, to make sure that things were in order, we also employed a tool called USINET that calculates more advanced network statistics. So for centrality measures correlated with ICAP, we performed node level t-tests with USINET. So, and that was the base to draw a couple of networks that more significantly reflect ICAP across ages. So those are the networks that appear in our paper. You can notice that youngsters were better at idea generation, and seniors were better at connecting key concepts, which are constantly connected in these networks in the right. ICAP3 was related to discussions structured across ages. It was the only ICAP feature that we could detect in both. The active ICAP 1, constructive ICAP 7, and interactive ICAP 11 and 12 were related among students. 2 constructive ICAP were related among seniors. There were generational differences in terms of vocabulary. Others showed more agreement, positive mood, and confusion while learning than students. So we can notice that there are very specific needs according to age in computer-based collaborative learning. In the case of students, it's more regarding social skills, while in the case of elders, it has more to do with technological skills. Thank you very much.